Hello, good morning, good afternoon, and good evening to everyone who's tuning in. Hoping you're staying safe and doing well. On behalf of Biopetro, Arab Guru, Arab Oil and Gas Academy, SPE Egypt section, I'd like to welcome you all for our second session in the GIS and Spatial Data Visualization course. I'm Mayar, third year gas and petrochemical engineer student at Alexandria University, and I'll be your moderator for today. Before we start, please, I'd like to remind you to drop your questions in the Q&A section below. Please keep the chat box professional and ethical. And please don't forget to submit your quizzes before the deadline. Now, let us give a warm welcome to Dr. Tarek Kandakji, who will be giving us a session in the types and components of maps. Dr. Tarek is emerging academic with PhD in geosciences and demonstrated track record in conducting research in multidisciplinary environments such as international NGOs and universities. Areas of expertise include environmental science, earth science, ecology, atmosphere, air quality, water quality, geomorphology, hydrology, environmental health, land management, and land conservation. Strengths include geospatial analysis and modeling, GIS, remote sensing, and data analysis. Currently, Dr. Tor is working as a GIS coordinator at the city of Lubbock in Lubbock, Texas. Thank you, Dr. Tor, for coming today, and the mic is yours.
Thank you, Mayar, again today for your introduction, and thank you, Dr. Ahmed Al-Garhi, for preparing and organizing this session of seminars, and welcome you all to our second lecture. I hope you had a good time in yesterday's lecture. You learned something new, and it opened doors in your mind for the future and some application of GIS, like as an introductory vision for that field. Today, we will talk about how to move this. Okay, there it is. Okay, so in this course, today's lecture, we're going to discuss the types and components of maps. Last time we completed the definition of GIS, and we talked about some main concepts in GIS. What are the components of the computer system? We talked about the functions, the main functions of GIS, and we said that the main function of GIS is to do a series of steps. It will end up in displaying the data, and what we care about is the final product, what information the final product will give us, how we can introduce it to other people, to people who are not specialized in our field, who like normal users who just look at it and get new information from the map itself. That being said, then we need to understand what are the components and what are the types of maps. Once you understand your question and your purpose for producing the map, you can choose the types we are gonna mention in a second. So what's a map, basically? A map is a model. It's just a representation of the real life situation. It's a model of selected characteristics of a place, usually drawn on a flat surface. Especially before the invention of technology, before the computer technology and all that stuff, people used to have only paper, like plain paper. And so the map is a model for these places and geographic locations. And then we have that model to help us understand where we are, how to move from one place to another, how to connect in terms of war, to decide on war and peace decisions and all that stuff. So in GIS, maps are dynamic. They are not static. It does not necessarily to be a fixed feature. It's dynamic. It changes with time. It changes with changing of information. That's why it's important. If it's static, then you cannot change it, then there's no use of it. It will be outdated at a certain point of time. But since it's dynamic, it keeps always updating based on the information and whatever happening in that location. Also, maps are able to reveal details as you zoom in or zoom out. So if you have a map, if you zoom in that map, if you scroll down to that map, you should be able to see more details. Sometimes your data quality will not help you to do that, but if it's better if you can choose data with high quality and high resolution that will allow you to zoom in and you zoom out. And this is also appropriate. It's a good thing for visualizing purposes. Like if you're looking at the map in a whole, like the whole world, then you don't want you don't want the map to be crowded and full of information that you may not necessarily know. So when you zoom in to a certain specific location, then that's where you want to see the details. So the map should have this ability, and that's one of the reason why it's dynamic, because when you zoom in, you will show more details than if you are zoomed out. Also, maps contain many layers. You have many, you can put in a map many layers and stack them and overlay them over each other. You may have like a country base map. Then on that map, you have population density, or let's say population of per governorate or per certain place. It will be in points or other polygon on top of that. So you can put as many layer as you want to see how those features interact with each other to finally give you the information you want. And in the analysis, which we're going to learn in the last lecture, we can use that in suitability analysis to determine the place that's most suitable for certain task or certain environment. So, and also this is why it's dynamic, because you can turn on and off the layers you want, you don't want, like, or you want. Like if you want this layer, you just turn it on, keep it on. If you don't want it, you just turn it off. You don't remove it. You don't necessarily remove it from your database. You just don't visualize it. The other component, like the other characteristic of maps, is they are able to access more information about features. Each layer you have is a feature, and there are information associated with that feature. So it's very important to understand this concept. You have many information that you want to analyze, you want to understand, you want to show to people. Then these information are associated with the feature you have, and you can access it. Editable and ready for analysis. The map is editable. You can change the symbology, you can change the data, you can remove data, you can add data, remove certain information, add another information, and ready for analysis. You perform, you answer questions with these data. Like our best example is population. Like you can analyze the data to show you population density in a certain country. Like in, let's say, for example, in Saudi Arabia, like you have many governorates and many regions. You can measure the population density and see where people are mostly located. And maybe those people need access to like the people with low population density, like areas with low population density might need access to healthcare system, may need access to educational system. So it will help you to analyze the situation you have. As we said, maps are model of the real world. This is what a map is. Accordingly, maps are scaled to realistically represent the real world. Like when you look at the map, you're looking at your computer screen. Computer screen is probably at best like what, 29 inches, or a huge TV. What's a huge TV? Let's say like 73 inches. It's still, if you want to show the whole world, it's a scaled world. Like you are shrinking the whole Earth in a small screen size. Then this is what we call scaling, and we're going to talk more about scaling in the future. But the maps do not represent the real measurements of the location we are analyzing or we are studying. It only scale it down to appropriately be represented on a screen. Now, maps cannot show everything, and the information provided by the maps are limited to the layers included in it. Like, don't expect to see everything in a map. If you see a map of the whole world, don't expect that you will have all the information. No, it's limited to what you have, what are the layers you're using. Details of real world features cannot all be shown in a map, and this is why we are limited to the layers that included in it. Therefore, all maps are not perfect reflection of reality. Not every map you see is a reflection of what's going on. Like, sometimes some people lie with maps. Like, I can change the symbology of the map to misguide the viewer to a certain objective I want. I can easily do that in maps. Of course, people will react to it, but eventually you can change this. You can manipulate the information in any way possible. That's why we need honesty, and you should have ethics when dealing with maps, and be sure to show the information as it is without any manipulation. Uh, Based on the purpose of your data, we have several types of maps. We have general reference map, which is the first type of maps. We have cadastral maps, or the plat maps, or parcel maps. We have navigation chart maps. We have qualitative thematic maps and quantitative thematic maps. You can combine 4 and 5 in one type, which is the thematic map, and you have the subtypes of qualitative and quantitative. But I prefer to discuss them separately because each one has its own characteristics. Although it will not, some people may say it as it's still one type of map, but that's not a big problem. We can discuss that later on. Now, the first type of maps, the general reference maps. These maps are used for general identification. Like, if you want to present general information, when you go for a famous tourist site, like sightings, like in Egypt, if you go to the pyramids, or in the United States, if you go to Hoover Dam, those important features, historical features. Sometimes they distribute maps with them, small maps that shows you the location where you want to go in the museum or in any place. Those maps are general identification maps for general purposes. They do not have a scientific or analytical purpose. It's just for showing information. Those examples are topographic maps, road maps, atlas map. The atlas, when you have in your hand the atlas maps, it's all part of general reference map. These maps are useful for government agencies like CIA, USDA, USGS. Why? Because it gives you information. Like, if you have a highway map for a certain region, they might use it. It can, for government agencies, they can use it. So it has multiple applications, but it only gives general idea and general information. Another example is map produced by National Geographic and other media outlets are also example of general reference maps. These maps are very common among people, especially tourists, hikers, etc. Like, if you want to hike in a mountain, you have the map with you. That's a general reference map. It does not provide any detailed information. Now, the other type of maps is the cadastral maps. What's cadastre? Cadastre is a registry of property showing the extent, value, and ownership of lands. So, for example, if we look here, like this parcel here in the yellow square, like each yellow shape here is a parcel, like a piece of land owned by someone, has a certain value. It has geographic extent. So cadastral maps shows you these parcels, shows you this ownership, like divide the map into pieces. So when you look at it, you can, like, if you want to buy a house, you go to that map and you see the location of the house and what's the geographic extent of that house. You can also see the price of that house. What's the price? And the the taxes. Some countries apply taxes on parcels and houses, so you can see what's the tax amount on that house, the ownership, who owns it now, and if there are any other information, like if there's any citations or some kind of notes in there. So cadastral map is focused on land ownership and parcels in a certain region. Uh, and it also shows the parcels in relation to each other. Like, what's the name? Where are they located? What's the neighborhood they're located in? And how far are they from the main road, from the highway? Are they in a calm area? Are they within a walking distance of a shopping center or a school? Like, all that information. These applications is very famous for local government. Me at the city of Lubbock here, we use that type of maps a lot. I work with utility with the Lubbock Power and Light, which is utility line for electricity. So sometimes we are interested in seeing how the electric powers are crossing people's land. So we use this type of maps, the cadastral maps, to see if we want to build or we want to install electric line, we see, is that electric line going to cross a certain house? If And we take measures accordingly. So, and also it's very important for real estate agents and potential customers continuously use these maps in their business. Like, if you want to buy a house, if you want to sell a house, it's very important to have such information. It will save your time and save your customers' time. The other very important type of maps, it's the navigation chart maps. From the title, it's used for navigation mainly in air and sea. Like, when you are in an airplane, you have this map that shows you where you're going, and the airplane is going from point A to point B. These can be navigation map, but these maps are mainly used in military purposes and airline companies, especially in military purposes, because the military want to go from one point A to point B without being noticed by the enemy or anything else, or if they want to do some sort of investment in a certain country. Like, all this information is very important in military purposes, and also airline companies. Like, airlines, when they want to decide the pathway of the airplane, they use navigation chart maps, and it's very important. Like, as you see here, this one is for this map here is for airline data, how the when the airplane is flying and the pilot needs to know where they are and how they need to move. This map here is for the Navy, and this also here for one of the Navy forces, how they navigate in that region. It's very important. Now let's go talk about the thematic mappers, which is the maps that we are most interested in. Like, in all fields, majority of the fields are mostly interested in the thematic maps. So these thematic maps usually focus on one feature. Like, unlike the general reference map, like the general reference map, we said it has many features, many information. The navigation map, it may have many information, like all that stuff. However, the thematic maps usually focus on a certain topic, like, for example, land use, temperature, all that stuff. Like, it's only one feature you're focusing on. Therefore, based on that feature, we can divide the thematic maps. It could be qualitative and it could be quantitative. When we're talking about qualitative thematic maps, it includes descriptive and non-numeric information like land use and geomorphology. Those are all the type of the qualitative. Qualitative means not numerical, basically. So if you have a category, it's categorized. And as I said, for example, land use, if this land is agricultural land, or if this land is bare land, or if this land is desert. So this land use is described by text. Assigning a value to it will be meaningless. So based on that description, we call it qualitative maps. Now, those qualitative maps has attributes in it. Like, each category in that map has descriptive value in a descriptive text in the attribute table. And we're going to see that in an example after we're done with this. So it's, as we said the last time, there's a shape, there's an attribute table associated with each feature, and that descriptive text will be shown in that table. Then if you want to display it on the map, you can label the map or you can add the symbology to it, as we will see later on. Now, the other type of thematic maps is the quantitative thematic maps. And these maps are used for classification based on measured numerical value. It has a value, not only a category, it has a certain value. Features with similar numerical values are grouped together and given the same symbol on a map. Like if you have, let's say, population density of in different regions, then those features, especially when we're talking about raster data and not the continuous, the discrete raster data. You remember the last time when we said that rasters image information, each pixel with the same value, it will be put in one record. That's what will happen. Like numerical values are grouped by a given same symbol if they have the same value. Now, these maps can be used to show population, precipitation, temperature, etc. These maps are very useful to conduct spatial and statistical analysis. If you want to do quantitative analysis, not qualitative, you want to do quantitative analysis, apply certain statistical methodologies, then you need quantitative thematic maps. Qualitative thematic maps may not necessarily be helpful unless maybe you're doing some sort of qualitative analysis. But in terms of quantitative analysis and spatial statistics, it's better to use quantitative thematic maps. And by the way, sometimes the data you have will not allow you to have quantitative values. Then you can use other statistical methods that can tackle qualitative data and produce results. Now let's go back to the point we mentioned at the beginning. Not every map is informative. And if a map is missing an important element, then it will be misleading and it will not be visually appealing. Remember last lecture when we talked about if you made a very delicious food, but you present it in a not nice way, like if you have, let's say, rice and chicken and some fried almond on top of it, like you can put it in a very, very appealing way. Like you have the plate of rice, the very beautiful cooked rice, and you spread maybe almond on top of it and the piece of chicken on top. That will be visually appealing. You can put some cilantros on the edges. Like you can present it in a very good way. Now, even if it's not delicious, even if you're a horrible cook, but when people look at it, their mouths start to water and like, yeah, it's delicious. I'm gonna eat it. So the same thing with maps. If your map is visually appealing, people will want to look at it. People will want to learn from it. But in our chicken and rice dish, if the chicken is mixed with the rice is mixed with the nuts, the cilantros, or nothing, or if you don't put any other coloring on the dish, people will look at it but may underestimate and say, well, yeah, that could be a good dish. And when they eat it, it might be very delicious. But the presentation of that dish is not good. So the same thing with maps. You need to have your maps visually appealing and includes information as much as you can. Now, speaking of that, there are 6 main elements. And by the way, not all 6 elements are necessary. And sometimes you need to add more than 6 elements. It all depends on the purpose and why you are using the maps. But those 6 elements are mostly common, and I advise everyone who's making a map to include all these elements, which is the title of the map, the legend, the scale, the direction or the north arrow, like the orientation of the map, the labels, and grids if necessary. And we're going to talk in more details about these elements. So the map title. Title of the map is the keyword. it's the first thing the some people look at. Like if I'm looking at the map, the first thing I will I will look at is the title. Why? Because I want to know what this map is talking about. So a title will be the keyword will give you will it's the first hint to what or the first information that tells you about the purpose of the map. Sometimes if you don't have a title, the viewer may struggle to understand why you're presenting this information. Like for example, the population density map, some people may look here and say like, okay, persons per square mile, okay, that's density, but why is there's another purpose? But if you put the on the title Ohio population density, people will understand the reason behind this, the reason behind making the map. Like you want to show the population density of the state of Ohio. Um, the keyword or the title, it's better to choose the short and the most informative title. Sometimes you can describe your work or you can describe the map with a very long text, but that will take long for people to read, so they will just not look at it. So it's best to use the shortest and the most informative. And the title should be placed on an obvious location on the map, and it should be clearly visible. Like you don't just put it on the one of the corners with a small font line. No, it has to be highlighted. It has to be clear and obvious. Nobody will struggle in seeing it. Now, the next, this is very the map title is very important. It's very essential. Now, the other most important element is the map legend. Map legend is basically your map. Simple. It's your map. It's what you want to show. Like if you have a map with colors with no legend, it will be useless, completely useless. The legend I'm talking about is the code, is the code description. Like, uh, for example, in this map here, Ohio population, see these colors? You have red, dark red, regular red, light red, white. These are information. Like if I look at it without the legend here, I will not know what the white color is for. I don't will not know what the red color is for. So the legend, if you have a map without a legend, then it's not good. And like if you are publishing a paper and you show a map without the legend, a reviewer will send you back the manuscript and tells you, well, I need the legend. I need to know what these information are. So it's the key to translate the codes, the color codes and the features in your map. And any map without legend is meaningless. Honestly, if you have codes and you don't have a legend, then your map is meaningless and useless and nobody will be able to use it. The other most important thing is the map scale. You remember when we said that the map is not representation, is not scaled to represent the actual measurements of the real world? That's where the scale comes in. Like if you have the whole, let's say, Africa continent, and you have, let's say, the countries in Africa, countries in the African continent. So you put it in a map, but the map is small. It can fit on your screen. No matter how big is the screen, no matter how big the paper you are, it's still not the actual size of Africa. There are measurement units. So each centimeter or each millimeter in the map is actually related to a certain measurement on real life, and that's the scale. So you can relate the distance on the map to the real world. A scale on a map can be in many forms. It could be a ratio or a scale bar, and we're gonna see them right now. Like example, scale 1 to 10,000. Like if you see a map and it says scale 1 to 10,000, that means that one unit on the map equals to 10,000 miles. Now that unit can be 1 centimeters, it can be 1 inch in the map, and we will explain that later on. So for example, this scale here is scale from 0 to 300 kilometers. So when you look at the map, any feature distance between features that this much in the map, then that means that's 75 kilometers apart on real world. Another way to put the scale is you can put it in a ratio, like 1 to 25,000, as in this example here, or you can just a scale bar, like it's going to be a ratio or a scale bar, or simply a test or a text. Like, for example, here you said 1 centimeter represents 250 meters. That's it. And people usually know how the centimeter look on a surface on a piece of paper. So when people look at the map, they say, okay, 1 centimeter means 250 meters. So this country is such and such centimeters apart. And oh yeah, that's how it should be, the distance between those two countries or those two cities. Like if you have cities A and B shown on the map, visually using the scale, you can estimate the distance between those two cities, even if you don't know what the distance in the real world actually is. But let's say the example between Cairo and Tripoli. If you look at the map and you have the scale, you can estimate the distance, even if you don't actually know it. So this is one of the reasons why it's important to use the scale. The other component of the map is the north arrow. So usually the map is default. The upper side is north, the lower side is south, right is east, and left is west. So these, it's a default, but sometimes the nature of your data forces you to make some sort of orientation. So this element is important to guide the viewer to the orientation and how the map is actually presented. Although most people tend to be right to the north, the viewer should pay attention to the north arrow because don't take it for granted. Sometimes the person who created the map, they will be orienting it in some form, and then you need to show the north arrow. And here's how the north arrow are presented in ArcMap. Like there are several forms, and you can choose whatever more visually appealing to you or to the scheme of your map. The labels. This element is useful when the labeled feature is not needed to be in the legend. Like sometimes, like country names, you cannot color code each country in the world. Like if you have a map that's showing the countries and certain information about the country, like let's say the main imports or main exports of that country, or the main industry, or whatever, like the population of these countries. So it will be not feasible to color label all the countries to show their names. Like you already have color coding for the population or for the information you're using or you want to show. But it will not be possible to use another color code for the country and then have it in the legends. Instead, you just add a label. Like as the map here, this is Greenland, this is Alaska, this is North Africa, and all this information. Like you can label it instead of color coding. So map elements is important. Or you have a road map for a country and you have roads, then you cannot put a color code for each road and give it a name in the legend. You just label the road with the name of that street or that road. Now, the other important element, but it's not necessary, by the way, grids. Now it's the 6 elements. It's not necessary. It's not the end of the world if you don't include it, but it will be helpful to know the location of your study area, especially if you are not showing a famous location like a country. So people might wonder, okay, where is this study area is located? Like if you are doing, let's say, a desert in Egypt, you are doing some sort of ecological analysis on a certain desert in Egypt, but you only zooming into that location without showing the whole country. So people may ask, like, where is this, even though with the title, but they would like to see the idea. Even if you mentioned that in the title, people need to understand more in geographic aspect if you have the grids. The grids, it also helps to show the projection system. what type of projection system, which we're going to talk about that tomorrow. So it's what kind of, like, if it's a certain projection system, then I might know that the areas are exaggerated or the distances are exaggerated. So once you know the projection system, it will give you good information. And the grids and graticles are very important in showing the location of your features. Now, this is the end of the lecture part of this presentation, and I will move on to to demonstrate some features for you. I have a couple of documents, and let me start with this one. Can you guys see my screen? Can you see the maps? Mayar, Ahmed, is the maps visible?
Yes.
Okay, awesome. Good.
Yes,
Um,
yes.
Wonderful. So this is an example of data. There is another document I'm gonna open right now. Sometimes it takes time to load such documents. I want to show you several examples of what kind of information we can have. Okay, so while the other one opens, let us talk about this one. You have, for example, here a map of the world map. You have Egypt, and you have census data. This is a shapefile I downloaded from the internet. As you can see, there is a lot of information. And by the way, sometimes the data comes with data dictionary that can give you information about the shapefile you're having. Let's see here. Go to properties, go to symbology. Here's where you change the symbology. This is very important. Like, you use the color code. What kind of information you want to add. So it's all listed in here. And this is the field. You choose the field that you want to symbolize. As we said, there are many information in any shapefile. So you need to know what kind of what's the field you want to know, like what's the particular piece of information you want to show, and you can use color coding. Okay, this one opened finally. So here's an example of a map that I created before. So I was doing some analysis on drought in southwestern United States, and I wanted to build a map. So if you go to the layout view here, the map view, this is how the map looked like. You have, if I showed you this map, you will know nothing. You'll say, okay, what's this? Is there any information I can take from this? Well, you have the drought for a certain day of the year. And so for December 30th, for example, like you have, okay, and what's this? All what I see is colors, lines, points, some labels that represent the state name, like for example here, like state names, like, okay, but what's this? Is this any useful information? No, that's where we go to the map view of ArcGIS. The map view in ArcGIS is where you design your map. Here in the layout view of the ArcGIS, you work with the data. You analyze the data, you change the symbology, you change the line. Like for example here, for this, I would like to go to the drought information and change the color code. Like, okay, I will give it, let's say the 0, I want it to be like, let's say black, for example. You click OK, and you click OK. And here it is, it's becoming black. So this is the layout view of ArcMap. This is the data view of ArcMap, and this is where you manipulate and design how the features will look like. Now, once you're done with this, once you decided on the, let me go back to this one here. Oops. Once you decided on the final symbology and the final color coding, and by the way, when choosing the colors, you have to pay attention. Do not use colors that are close to each other. Like, for example, here I'm using yellow. This is drought map. Drought map, that one means uh, very low drought. Number two means higher level of drought. Number three means extreme drought. And 4 and 5, exceptional level of drought. Like this is kind of categories of drought. So this type of information is qualitative thematic map. It's not quantitative, it's qualitative thematic map. So let me open the attribute table for the drought. So these are the categories. Now, um, as I said, these features needs to be distinguished. Like I cannot put very close colors to each other in the symbology. Like I cannot use for category number 0 a color close, let's say, to this, for example. See this one and this one? Let's click OK. It's a little bit distinguishable, but people may get confused. Some people may not have the ability to visualize the color. And there's another reason, like not all people have the same high quality of monitor you have. So some people may have low quality monitors. So what to do in that case? You cannot choose colors that needs high quality monitor, because not all the people are using the same technology you are using. So basically you need to use something, a color scheme, a color grading that is suitable for everyone. Even you have people that are color blinded, then you have to be careful. You cannot use red and green on the same map, because that will give them problem. Then you need to choose another type of coloring. So in map design, choosing the color is very important, because as I said, people have different ways of visualizing the data. People have different ways of understanding, and that's why having distinguishable colors is very important. And another thing, like we said, this is a drought map, right? So the best color scheme, like when you have a very high dry areas, then you can assume that the temperature is going to be high. Then the red color is more alerting. And we're saying about drought. So if the value of a drought is high, then that's alerting, that's dangerous. So that's why I give it a color red and dark red. Like, oh, wow, this is kind of a dangerous situation. So you give the viewer the ability to understand what you want to say. Like if, like for example, if you're talking about population density or let's say drought here. Let's stick with our example, the drought. If you have the red color, then that will subconsciously infer for the viewer that, okay, this is not good because it's red, it's dangerous, it's not good. So the use of color also will help a lot in delivering the message you want to deliver for the viewer. They can understand what's going in your mind subconsciously in terms of this. Like if you have vegetation, like let's say I want to change this to green, like instead of yellow, let's say I want to put this as green. Then people, first of all, I didn't choose green because it doesn't fit well with the other colors. It's very odd. It's not gradual with the other colors. But it will be logical to use green here because one is the lowest level of drought. So that means green subconsciously can affect the viewer like, okay, green, that means it's good. It's not too bad. It's something good compared to red here. So this psychological effects are very important in dealing with maps. And there are, trust me, there are courses that take semesters, maybe many hours of courses that deals with map production and how to deliver the message you want. Like, and you can also change that by the symbology can be tricky. It can be tricky if I want, let's say, the election maps. If I'm against one candidate, I might label their territories with red, because that means they are dangerous, with the color that will be strong, that will increase the anxiety. But if you choose calmer color for your party or for your candidate, that will be more relieving for people. So you play on their psychological effects. So this is why important to deal with maps, and it's important to be very careful when you present your data, because not only on the visual level, but the subliminal messages, the subconscious messages you can send through the map, through the colors, through the schemes, are very important. So as I said here, I change, and again, one of important thing, you cannot have two features having the same color. And so people will be misguided to see like, okay, this color refers to what feature in the legend. Now, once you decide on this, and when you play around with your map, and you start to choose the perfect fit, and let's say also the size. For example, the labels here. Let's go to this one real quick and see how the labels actually look, the size of the labels. Let me see here. So yeah, okay. So this is the map. Let me go back with the extent. Some people may say that those fonts are not very much big, like the label. This is the label, by the way. UT, you remember when we talked about the label? Now I cannot color code. I can put the background for the states, but it will not be appealing because it will intersect, or it will be mixed with the colors of the other feature, with the drought index I have. So instead, I can just put labels. So we have labels here of the features, and you can change the size of the label. Like, let's say I want to put these as 36. See, you can change the size. You can also change the location, but this is not wise. Why do you think it's not wise? Because it will interfere with multiple categories here. It will mix the visual interpretation. It will mix with the visual interpretation. Now, if you see how this is changing, see, this is how my map will look like after I change the size of the label. So this is not good, and it must be changed back, and you use it wisely. Now, in this size option I'm having right now, you can see that the color scheme only fits within, and even that, by the way, it's not, it's shifted. Let me go back and fix it. So this is one of the things you want to swap between the layout view and the data view as much as you can. So I discovered that, okay, the location is not very much good. So I will move it a little bit this way and go back. And maybe put it down a little bit. Again, I'm going to select it and move like this. Now let's go back. Yeah, it's much better. Now it's much better. I can even change this because I don't want this to be here. I can do, which is even a better option, I can just choose Arizona and move it to the white part, so it will not interfere with the color scheme I have in any way. And maybe a little bit. Sometimes this location will be different if you use labeling in another way, you may not face that problem. But sometimes you face that problem if you convert the labels into annotations. Annotations means that they are text independent from the map itself. While the label, when you do the labeling, like let's go to the state information here, open attribute table. These are the state name. Now I can do the label normally. I go to properties, I go to label and the state. Maybe I want to make it bold. That's good. Okay. All right. And then I want to show that label, which is label features. So the labeling, sometimes it will be it will help in dealing with the data. And let me see, remove element. Okay, let's move it back and go to properties. And yeah, let's see. Let's see another type of labeling. Make it 16. Oh yeah, sorry. Of course it's not working. Oh, sorry, my mistake. Let me go back here. I was playing with another feature. So this is one of the things that you will face. Like you think you're dealing with a feature and then you're dealing with another feature. So it's very normal to have such confusion. But now, okay. See, here it is. Now, here's the label you have. This is the default labeling of ArcMap. You can change that default labeling, but changing that label, if you change one, then you're gonna change the whole thing, and you cannot choose the location you want for each label. It's automatic. It's controlled by ArcMap. So alternatively, what you can do, you can convert these labels to annotations. Annotations means it's a simple text, independent from ArcGIS and independent from the feature itself. So it will be like a standalone text. It's like you manually went there and added a text for each map. And this text is not included in the attribute table. So you are basically telling ArcGIS, take that field from the attribute table, make a copy of it, but outside the feature and outside the location. I will change it later. I'll play with it. So just take it away from the attribute table and I will manage it. So this is one of the ways to manipulate your data. When the labeling scheme is not working, you can convert it to annotation and change it. So eventually, I use this. So this process, sometimes it can create problems when creating the annotation, especially with the scaling and labeling. So now, after the final product of our map is this one. Let me turn off the label for these because it was added. Okay. So this is the final product. Now I want to give information for the reader. Now, because I'm dealing with professional people who are professional in my field, then it will not have a lot of information. And because I'm presenting it in a paper form, the title was included in the paper, but we can add a title here. Let's add a title. We can insert title, and let's name it drought and dust point sources selected drought events and dust point sources and the associated dust point sources and the associated okay. So basically, what I was doing here is detect dust point sources. You know, the dust storms. I was detecting the point sources of dust, where the dust is coming from, and I put that over a drought map so people can see the points of the dust, what kind of drought event, drought condition was in that region. So, and then we put the title here. Of course, you can, let's see if we can move it up a little bit. I don't think so, but let's see. Okay, it will not fit. So what we do is we change the size of the title. Okay. So selected drought events and the associated dust point sources. And change the symbol. Let's make it to fit the size 14. 14 is good. Maybe make it bold. Okay. All right. What we can do is make that into 2 lines. Maybe that will help us. Change the symbol. 14. Let's make it even less than 14. Maybe let's try 8. And this is the scale bar. So the scale bar tells you that this distance from here to here on the map equals to 150. So you can say that this let's measure this distance here based on the scale. So this distance is equivalent to this visually. So you can say that the distance between this point and this point in Texas is roughly 300 kilometers, and we can check it later on. But this is the importance of a scale. Now let's go back to our title and change it maybe to 10. Okay, there it is. Now, I think we can be a little bit, well, maybe 12 is exaggerated. Let's do 12. Click OK. All right. And we can move the north arrow to another location, maybe in here, just to give. See, this is how we design the map. This is one of the ways to design the map. So selected, we say that we put the title as selected drought events and associated dust point sources. People will know what we're talking about. You have the legend. This tells you that these colors points are the dust point sources. The polygons around it are the drought level. This is the other feature, the southern high plains, and all the other features we're showing here. Now this is the scale. It's very important, as I said. So let's say, as you see here, the distance between this point and this point. So let's say if we move the scale, let's say move the scale here, see? At the Texas Panhandle. So Texas Panhandle, it's kind of little bit less than 300 kilometer in length. So this is what the scale is. It tells you what's the distance. So if you put the scale on top of the map, it says that, okay, this is less than 300 kilometers, like probably 280 or something like that. Well, let's go to the map and measure it. Let's go to the map here. And we have the measure tool. And let's measure this. Let me see. I will zoom in a little bit. Okay, Now I'm going to choose the distance in kilometers, and I'm going to change that to from here all the way to here. See, the distance is 269 kilometers, which matches what the scale told us, what the information the scaled system here showed us. Now you can add, if you want the scale, you can add insert scale text. Maybe 1 centimeter equals this, for example. So here the scale tells you that 1 centimeters equals 433. But me personally, I like the scale bar, because the scale bar you can directly associate it with the map. You can visually and hypothetically put your scale here on top of the map. You can do it by your mind, by visual power. You can, by your visual ability, you can put it here and see how it will change. So in my opinion, I prefer to use scale bar because it's more informative. You can quickly relate the size of the map to the size to the real world size. And the north arrow is very important. Here the north arrow tells you that up is north, and you have the inset map. Inset map tells you, instead of using the grids, which I already used here, grids here tells you maybe about the projection system and how it's presented. But the inset map is another easier way for people who are not familiar with the geographic location. Like some people who are familiar, they look at it, okay, this is 110 west, between 100 and 100 west, and 336 and 33 north. Oh, that could be a region in Texas, a region the panhandle in Texas. So people can relate, but there are people who are not aware. They do not know the size or the geographic location, so they use the inset map. Inset map, basically, it's a square here. This square tells you the study area. So when you look at it, like, okay, this is all United States, and this square is where the study area is located, the study region. This is where I'm studying the information. So, and eventually, you will have this map, and let me show you the map as a picture real quick. The final output of the map, it's gonna be somewhere on here. Just quick. Okay, the figures, and this is how the image looks like. I'm trying to bring it in. Okay, so this is how the image looks like. See, this is how my maps look like. And of course, there should be the title. Let me export it real quick because it doesn't show the title well. Once you do export the map to PDF, and you can choose whatever. You can choose PDF, JPEG, or whatever information. Let's now export it as a picture, and you give it a name, any name distinct like drought and dust, and you can save it, and then go back. See, it's exporting. Okay. And here's the map. So here's the map, here's the title. Like if you look at it as a normal person or expert or even non-expert, you look at it, you say selected drought events and the associated dust point sources. Okay, let me look at this. Here are, okay, where are the dust point sources? Oh, here they are, dust point sources. Here's the pink. What the pink is for? Oh, the pink is for March 8, 2002. Nice, so this is for 2002. What kind of drought event there? Oh, there's abnormal drought event, and there's moderate drought event and severe drought event. There's no extreme, and most of the dust point sources occurred on the moderate drought event. Oh, look at this map. It has red. Wow, red is very strong. Is something wrong going on here? Let's see. It's the green color. The green color is for the light green because there's dark green, there's light green. It's for March 18th, 2014. Let me see. Oh, there's a lot of drought event. Most of the point sources coming from the high drought areas, like the extreme drought and the exceptional drought, like this point here. These points are mostly in the drought. And okay, so where the points are located, this is within the blue polygon. The blue polygon is southern high plains. Oh wow, this is very useful information. And that's how you deliver your map. This is, you want the viewer to do this, what I just did, in their mind. I was thinking out loud, and you want the viewer, the person who want to see the map, to think out loud in that way and start to analyze your map, start to get the information. So if you show this to any non-expert, anyone who's not expert will tell you, okay, apparently there is influence of drought on the there's influence of drought on dust emission. And there's one thing wrong here, which is, let me go back and fix it real quick. Well, it's, we don't have time for that now, but this is basically how the maps will look like. And this is how we design maps. And of course, always your first map, it's not going to be perfect. Like the first map I made was lousy, was weak. Like everyone who start doing GIS and do cartography and do mapping, it will not be perfect. There's always a room for mistake. But the more experience you have and the more reaction you get, because if you have more experience, like people, you'll have more experience in people reacting to your product, whether you're advisor or if you go to a conference. Once you build that in experience in people reacting, you know what people will want to see. And ArcGIS is full of capabilities, and ArcMaps full of capabilities of visually appealing. And this is only one example. If we have the time, there's actually cartography. The lecture we covered today, there's a course called cartography in universities and in GIS majors. Sometimes it extends to 2 semesters. It only deals about what the map is, how to design the map, how to understand the psychological effect of the maps on the viewer, on the people, how you can even change mind by changing symbology. Like, as I said, in politics, your opponents, you can symbolize them with strong colors like red color or black color, or like something very intense and hard. But your own party or your people or your own message, you can symbolize it with calmer colors like green, blue, those colors that makes you feel comfortable, and that will play on the psychology of the people. So it's all about how you present your data in an appealing way and give the information you want. Sorry, I'm 8 minutes over my allowed time. I'm done. If we have any questions, and again, I'm sorry for going 8 minutes late, and thank you for listening.
Thank you, Dr. Tarek, for this super informative webinar. Thank you so much. I see that your explanation was quite clear and obvious, because we don't have questions for today. So thank you so much. And now, to highlight, this session was recorded and will be uploaded on BioParo and Arab Guru YouTube channels. So please make sure to subscribe on both of them. Thank you so much. Have a good day, and bye.